today we're going to talk about absolute value equations and get ready to start talking about inequalities. So 1D is going to be broken up into two parts. Part 1 is equations. Take a minute and get your next page in your notes set up. 1D, absolute value equations and inequalities. Part 1, equations. We're going to start with a real life example. Have you done any baking? I know we've done a lot of baking lately. We like to bake cookies. I got a new donut pan where we use cake mixes and kind of doctor them up with, I don't know, chocolate chips and all sorts of good stuff. And then we frost them and they look like these cute little donuts. So much fun. All right, anyway, here's our real life example. The oven is preheating to 350 degrees, comma, within 5 degrees. All right, so what's going on here is the ovens are regulated to, come to a certain temperature, but if they stay within a couple of degrees of that actual temperature, they'll probably still read 350 and your oven will be, it'll ding, preheat, ready to go. Some ovens, in my experience, run a little bit hotter, some run a little bit colder. And that's kind of a factory setting. It's an okay thing. All right, so what does this mean then? It means that if the light's on my oven, that it's preheated, the temperature inside my oven is probably 350 degrees, but it could be as cool as 345 degrees, or it could be as hot as 355 degrees. So this inequality, or this number line, represents all of the possibilities for the temperature of the inside of my oven if it has been supposedly preheated to 350 degrees. All right, so that's kind of a real-world example, and we can visualize it pretty easily on the number line, but can we write an equation to represent this? And that's what we're going to really be working on in the next few days. All right, so what I can do here is I can say that the absolute value of my oven is within 5 degrees. So inside my absolute value bars, then I put x minus 350. And you're probably thinking, why minus 350? Why not plus 350? Well, this came from, here's my thought bubble. This came from x is 350, but to move it over to the other side, x minus 350 gives me a 0. We're going to talk more about that as being a 0 or a root of an equation in further chapters further on out in the textbook. But anyway, it's x minus 350 because x is equal to 350, and if I set the equation equal to 0, that's what I need that expression to look like. So 350 is my central value, and then I can be high or low by 5 degrees and still have my oven preheated to 350 degrees. Okay, so now if I'm going to figure out, what are some possibilities for my temperature in my oven when it's preheated to 350, to solve the equation x minus 350 is equal to 5, I need to consider the high end and the low end. I need to consider the high end where x minus 350 is equal to 5, positive 5 on the high side, and I guess, x minus 350 is equal to negative 5, or that's on the low side. So I can be high by 5 degrees or I can be low by 5 degrees, and that low by 5 degrees is represented with a negative 5. Okay, so to solve, my math is going to look the same for both of these cute little equations. Adding 350 but my solutions will be different. One solution is 355, my other solution is 345, and there we go. We get that range from 345 to 355 is 5 degrees on either side of 350. So, kind of the big takeaway or the moral of the story here, when you're solving absolute value equations, you're going to get two solutions. 2 solutions. Let's do a couple of examples here. All right, so if you still have room on this page, let's keep working. I do, so I'm going to say that example A is the absolute value of 2x minus 1 is equal to 5. Absolute value equations. We have to consider the high side and the low side, because when we're talking absolute value, we're talking about a distance from a central location. My central location being 2x minus 1. 5 being the range. This is my range. And I can be high by 5, and then I could also be low by 5. When I'm low, that means a negative 5 is going to be what I'm taking away from that central value. I'm moving in the left. I'm moving to the left, moving in the negative direction. Okay, then my absolute value expression goes in both equations. Absolute value is talking about a distance from a central value. On the high side, on the low side, you have to consider both ranges. Now my math is going to look the same for both equations. So here I am just doing the happy math. My first solution is x is equal to 3. Again, my math is looking the same. Same steps anyway, different numbers. My second solution is x is equal to negative 2. My other solution is x equals negative 2. All right, so if my central value is 2x minus 1, and I go 5 to the left, I'll be at negative 2. If I go 5 to the right, my solution would be 3, or I'll be at 3 on the number line. Absolute value, you have to have 2 equations. I'm going to tell you a little secret here. When I used to teach Algebra 1, I used to get so frustrated because I'd throw an absolute value problem at my students, and they'd only give me one solution. And I'd be like, kids, what do you think the absolute value bars mean? You can't just solve it like normal. Come on, absolute value bars. There's 2 bars. Use that as a reminder. You need 2 solutions. 2 bars. Why are there 2 bars there? Well, to represent absolute value, but also to remind you, give me 2 solutions. And of course, that's kind of just a silly simplification, but I used to really get frustrated. All right, so here we go with this next example. Did you get a chance to write it down while I was rambling about my frustrations way back when? I'm going to erase this. I don't like it so thick. Okay, so here we go. Now, please promise me that you will never, ever, 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 ever in your whole entire life, promise me, you will never distribute over absolute value bars. That's like the worst thing you could do. It's not the worst thing you could do, but it's not something we need to have done. Don't do it. Okay, so don't distribute over the absolute value bars. Instead, what we're going to do is we are going to isolate your absolute value. So what that means is we're going to just move everything else around the absolute value bars. Check this out. I'm doing this one step at a time. 3 is being multiplied by the absolute value junk. So undoing multiplication with division, divide both sides by 3. Okay, so here we go. Now I have the absolute value of x plus 2 is equal to 3. Okay, we've isolated the absolute value bars, and now we're down to a problem just like problem A, where we need to consider the high side and the low side. So central value is x plus 2. I need to consider going 3 units on the high side or 3 units to the right on the number line. I also need to consider going 3 units on the low side or 3 units to the left on the number line. So with absolute value, remember, you're always going to have 2 solutions. Your math, your steps will be similar, but your solutions will be quite different. So, whoa, I almost said 5 here. No, 3 minus 2 is just a 1. Okay, so one of my solutions is 1. Over here is where I'm going to end up with that 5, but it's going to be a negative 5. Okay, so x equals 1 and x equals negative 5. I had absolute value bars in my original equation, which means I'm going to come up with 2 solutions, a range of 3 away from my central value. 3 on the high side or to the right, 3 on the low side or to the left. All right, I'm going to have you write one more problem down. This is letter C. This problem is the absolute value of 3x plus 2 equals 4x plus 5. This is kind of a toughie. This is a brain buster. I'm not going to solve it right now, but I'd like you to think about what should we do here? What's different about this problem than the other two that we've worked with so far is that you have a variable inside absolute value bars and you have a variable, the x, on the outside over there on the right-hand side. What are we going to do about that? We need to go on the high side and we need to go on the low side of that central value, a range of an expression 4x plus 5. All right, so take a minute and think about it. Maybe take a few minutes and try and solve it. We're going to start there tomorrow. Remember, you're going to take a picture of your notes up through example B. If you do C, that's great. Show me a picture of that too. I only want one picture attached to the document in a Google Classroom, and then you're going to hit turn it in. We're doing great, guys. Thanks.